Right, welcome everybody to our 2022 BBCS webinar. We are thrilled to have you all today in this event. The topic of today's webinar is Global Prosperity in the Face of Climate Change in Pursuit of a Sustainable Future. So this event will inform us how to approach the issue of global sustainable development in the face of climate change and natural resource degradation from the standpoint of harmonious coexistence of natural ecosystems and human society. The format of the webinar includes an introductory session, and in this session, we will run an initial poll to know a little bit about you and your interests. And later on, we will get an introductory talk about our BBCS program. After the introductory session, there will be 3 talks from the invited speakers, followed by a moderated panel discussion with Q&A from the audience. We will take 1 or 2 questions if we have time after each talk. Otherwise, please place your questions in Q&A. After the panel discussion, we will close the event, and if we have time, we will run another post-webinar poll. And I hope the webinar will be fruitful for everyone present here. And feel free to contact us for any technical difficulty you face, as we know that the technology loves to fail when we most need it to work. And thank you once again for joining us. Now you will see the poll questions on your screen, and please answer them and hit submit. So we got the result from the poll. It says that most of us in this event is academic, 73%, and there are nearly 30% are students. And the field, the best describes the people's interest here, mostly ecology and economics and public health. And the topic inspired the people to join the webinar today, mostly the sustainable future and the climate change, and obviously the guest speakers there. So these are the 3 reasons and also climate change is also 40% of our respondents respond that they are interested to know. So this in a brief, this is the composition of our attendees today. So now we are going to know about BBCS and its mission from Dr. Casey Ernst. Dr. Ernst is a professor and program director of epidemiology of College of Public Health at the University of Arizona. She is a co-director and a founding member of the BBCS program. So her primary projects, so she is an infectious disease epidemiologist. Her primary projects examine the environmental determinants of vector-borne diseases, disease transmission and control, primarily dengue and malaria. So please welcome Professor Casey Ernst.
Thank you very much, Abu. So I just want to give you all a little bit of a background on the Bridging Biodiversity and Conservation Science initiative. This is a postdoctoral mentoring, research, and training program. And so Dr. Cabrera is one of our postdoctoral fellows that we have trained throughout the time that we've had this program in place. And so the mission of BBCS is really to position the University of Arizona as a leader for research that addresses fundamental and critical questions related to how biodiversity and conservation affect human health, well-being, and security in the face of climate and other anthropogenic changes. One of our strong missions is to train the next generation of interdisciplinary researchers, such as Abu, and to develop high-profile interdisciplinary research. And we have also a history of hosting events like this to communicate the science more broadly across the U of A as well as with the public. And there are a lot of different disciplines that are represented within the BBCS. We have myself as an epidemiologist. We have, of course, folks who are experts in biodiversity and conservation, as well as governance, public administration, public policy, informatics. So we really are bringing together a broad team to try to look at how we can address these issues. Go to the next slide here. So some of the current projects and previous projects that we've done, I just wanted to highlight some of the work from our postdoctoral fellows. These are all lead publications that were led by at least one of our postdoctoral fellows. We have our very own Abu, who led with one of our speakers, Dr. Costanza, as well as one of our faculty, Jose Soto, a study to look at an index for human well-being in ecosystem-dependent communities. And this is a really fascinating piece of work that I don't know if it's going to be highlighted later on, but it's really an interesting way to try to tie together an indicator that can assess how ecosystem-dependent communities change under different scenarios, et cetera. Dr. Park looked at Darwin's naturalization conundrum. So trying to understand the reason behind why some invasive species take off in specific areas. And then we also had a project that we did looking at the policies in the role of policy and drought and how that increased the fires in the Amazon and how that led to biodiversity impacts. So our team is made up of two leads, myself as well as Dr. Inquist, who's also going to be hosting the panels today, Dr. Bashirs, Dr. Lean, Dr. Soto, and of course, Dr. Cabrera. And then we have a BBCS steering committee that is made up of a lot of other faculty across the college, which you can see here. And it would, it's of course important to mention Carrie Johnson, who is our fabulous program coordinator, who helped organize this event today. So shout out to Carrie. And our web address is bbcs.arizona.edu if you want to learn more information about what we're doing and the kinds of projects that we have going on. So thank you for letting me discuss a little bit about BBCS and what we're doing. If you're interested in working with us on some of these cross-disciplinary projects, please feel free to reach out to myself directly or to somebody else on the team. Thank you.
Thank you, Professor Ernst, for your brief introduction about the BBCS program and its research. So our speaker now is Dr. Christy Ebai. Dr. Christy Ebai is the director of the Center for Health and Global Environment and professor in public health science at the University of Washington. She has been conducting research and practice on the health risk of climate variability and change for over 20 years, focusing on understanding sources of vulnerability, estimating current and future health risk of climate change, and designing adaptation policies and measures to reduce the risks of climate change in multi-stressors environment. She has supported multiple countries in Central America Europe, Africa, Asia, and the Pacific in assessing their vulnerabilities in implementing adaptation policies and programs. She has been an author on multiple national and international climate change assessments, including the IPCC Special Report on Global Warming of 1.5 degrees Celsius. She has edited 4 books on aspects of climate change and has more than 200 publications. I now request Professor Ebai to provide her speech. So please welcome Professor Ebai.
Thank you very much, and I really appreciate the opportunity to talk with you today and want to give my apologies. I'm going to have to leave at the top of the hour. So if you have questions, please do put them in the Q&A and I'll try and answer those after I talk about climate resilient and environmentally sustainable health systems. In thinking about the main topic of your seminar today and what we need to do to promote prosperity, I immediately started thinking about equity issues. And so equity is going to be core to much of what I talk about in the next few minutes. I wanted to start with this framing from the Working Group 2 contribution to the 6th assessment report from the IPCC. And the left just shows the world that we're in today, where we have a range of impacts from a changing climate on human and natural systems, shows the interactions amongst those systems and how climate change plays into what we are seeing on the ground. Climate change is a stress multiplier and takes our current inequities and exacerbates them in so many different dimensions. The little propeller diagram in the middle is something that's been used by the IPCC since about 2012. And it points out that as we look into the future, we're looking at risk, where risk is probability times consequence. And the risks of a changing climate, whether in health or other systems, are composed of 3 basic components. One are the hazards created by a changing climate. The second is who or what's exposed to those hazards, the human, the natural systems that are exposed. And the third is the underlying vulnerabilities, where that category includes not just vulnerabilities, but the capacity to manage. And it's important to look at the interactions of these 3 basic components of risk when thinking about climate change or biodiversity loss or other global environmental change, and look at those interactions to better understand how we can build more resilience and sustainability into our societies. As a bit of a background, the health risks of a changing climate, the figure shows at the top some of the elements that are changing. Carbon dioxide, of course, is causing climate change, but it's also causing pretty significant impacts on nutrition that I'll touch on briefly. And then we know about rising temperatures, sea level rise, increases in the frequency and intensity of extreme events. From the health side, it's important to note that those elements interact extensively with a wide range of demographic, socioeconomic, environmental, and other factors that then influence the magnitude and the pattern of the risks. So when we think about climate change or other global environmental change in health, we also have to look at those interactions, going back to that propeller diagram of thinking about the exposures, the vulnerabilities, the capacities, and how those play out, not just from the physical drivers, but also from our development choices. Those interactions then affect traditional exposure pathways in health. You can see those across the middle, extreme events across to the social factors. Underneath that is a list of some of the climate sensitive health outcomes we're concerned about. And you can see that it's a very long list. I have the privilege of spending quite a bit of time in low and middle income countries. And you see climate change cutting across almost everything that a Ministry of Health has to focus on. I personally think that climate change is going to fundamentally shift how we approach population health programs and policies. climate change, poverty, and other factors like inequities cut across all of the current programs. And those programs are stovepiped in ways that are not terribly responsive to a changing climate. And I'll talk about that in a moment. This is a summary, a word-dense slide, which we're never supposed to use, from the human health chapter of the AR6, the 6th assessment report from the IPCC. And you can see that we assessed with very high confidence that climate change is already affecting people. People are suffering and dying from climate change right now. We also, for the first time, had an extensive assessment of mental health and how climate change is affecting mental health. You can see in the lighter blue the big categories of climate-sensitive health outcomes. You can see on the bottom, the stars are the level of confidence in our key findings around these climate-sensitive health outcomes. I'm happy to talk about these more later if you're interested, but it is the point of this is a very broad field, and there's lots about which we need to be concerned. The other point is that when we think about climate-sensitive health outcomes, all of the ones of concern are current problems. There are places in the world dealing with dengue fever, dealing with floods, dealing with cholera. So there's policies and programs in place that attempt to control, prevent these kinds of climate-sensitive health outcomes. And so we have a lot on which we need to build. None of these programs were designed thinking about climate change, so all need to be modified in some way. These programs will need to be implemented in new places. There'll need to be adjustments, but we do have a basis from which to work. The other part of that is that there has been 150 years of research in population health looking at different climate-sensitive health outcomes. We have a deep understanding of which groups are more vulnerable. Vulnerable because of geography, vulnerable because of particular characteristics, the demographic structure of a community, for example, or vulnerable because of marginalization. And we need to address that when we talk about how we're going to better manage a changing climate so we do end up with a more sustainable future. One of many examples of the health impacts of a changing climate was the heat dome that occurred last June, the end of June last year, in Portland, Seattle, and Vancouver. You can see the temperatures broke records by extremely large amounts. Typically, when areas break their previous record, temperature record, you're talking about breaking records in tenths of degrees. It was unheard of that these temperatures were more than 10 degrees Fahrenheit higher than normal. There was a detection and attribution assessment completed on this heat dome. And at the end of that, the climatologist said that it was virtually impossible this event could have occurred without climate change. Across the region, the current estimate, and it's still being refined, is about 1,000 excess deaths. About 1,000 people who would not have died during this heat wave. The area was unprepared. It certainly is going to be prepared for the next one. And there were so many dimensions to look at in terms of what happened and what could have been done better. There was a 69-fold increase in hospitalizations. Our healthcare system in the middle of COVID was really, really stretched. Several of the emergency departments reported that they were basically at crisis levels. It was very difficult to manage the numbers of people who were coming in. And I'm focusing on health, but it was not just health. Our wheat crop was affected. It was at the height of our cherry picking season. We're one of 3 states that has protection for outdoor workers from the heat. And it was very difficult when you have temperatures of 112, which is probably not bad for some of you in Phoenix, but it's unheard of in Seattle. The event also occurred at low tide. So between around Portland and Vancouver, the temperatures in the Salish Sea were much higher than normal. And there was about 1 million mussels and clams that were cooked. That affects food security and livelihoods for many of the coastal tribes. So thinking from the perspective of health, I could talk about this event, but really want to make the point that these are all of society issues, and goes back to the points that Professor Ernst made about thinking in a systems-based approach and making sure that we are connecting the dots across human and natural systems. I also want to add to this that, as I mentioned before, there's growing interest in looking at mental health. There's very nice studies that have been done in England following some major floods they had several years ago. There's more studies in other places. And this study usefully separated those who were in a residence that was flooded from those that were in a residence that was disrupted versus those that were not flooded at all. And this is shortly after the event. You can see the very significant differences in probable depression, anxiety, and post-traumatic stress disorder. And these people were followed up, and 3 to 4 years later, the numbers have come down significantly for the flooded and the disrupted, but they're still higher than the not flooded, that these mental health consequences can last for a long period of time. Moving on to vector-borne diseases, something in which Professor Ernst is a worldwide expert. And I wanted to point out just a couple of things about vector-borne diseases. These are projections for the United States for the mosquito that can carry dengue fever, Zika virus, chikungunya, and yellow fever. And I'll start with the map on the left. The beige colored area are the projections of where we currently have this mosquito. They're projections because vector control programs are conducted at the state level. They're not a national activity. And there's variability from states to states in how they conduct their vector control program. And the projections then for towards the end of the century under high emissions, you can see really significant increase in the geographic range of this mosquito, including into Seattle. On the right, though, it makes the really important point. It's not just that you've got the mosquito there, but you have to have a summer that's hot enough and long enough that you can have disease transmission. And under these modeling parameters, you can see an expansion in range nowhere near as big as what was projected under just suitability. This was published in 2016. In 2017, breeding colonies of this mosquito were found in Toronto, Toledo, and Detroit. Like so many areas in climate change, it looks like we're under-projecting how quickly we're going to see impacts because we are not estimating appropriately how quickly, in this case, a mosquito takes advantage of warmer temperatures to increase its geographic range. This is the overall summary of observed impacts of climate change from the chapter, the human health chapter in the AR6. I've highlighted North America. You can see the impacts on human health and well-being, and saying across North America, the projections say increasing impacts on infectious diseases, heat, malnutrition, mental health, and displacement. So overall, what we're concerned about is making sure that we move from where we are today to a more resilient future. You can see the propeller diagram, slightly different configuration in this figure from the World Health Organization, and making the point that with a changing climate, we're going to have stresses and shocks. And with those stresses and shocks to our health systems, we're going to see a drop in the performance of those systems. And the question is, how are we going to respond and how are we going to recover? The aim, of course, is transformation. If not that, at least recover better than before. But that's not preordained. It depends on our investments in our health systems and making sure that we have sufficient investment and we are acting proactively and effectively. This is the summary then from the AR6 on the projected impacts. I showed you a little bit of that a moment ago, but just reinforcing that there is high to very high evidence on increasing impacts from a changing climate. And to take a moment aside, for those of you who are not aware of the shared socioeconomic pathways, these were developed in parallel to the representative concentration pathways, the emission pathways that people use. And these were developed to take a look at how societies could evolve over the course of this century, trying to describe that evolution without including climate change, so that at the end, there was a toolkit developed where scientists can combine the shared socioeconomic pathways with the emission pathways in different patterns to be able to answer different kinds of research questions. In this particular slide, I'm focusing on 3 of the shared socioeconomic pathways. The shared socioeconomic pathways are on 2 axes, one on challenges to adaptation, one on challenges to mitigation. And these are the pathways that are coherent with the challenges. So SSP1 is a world aiming to sustainable development, low challenges to adaptation and to mitigation. SSP2 is a world that muddles through, does some things well, kind of delayed, but continues along our current track, medium challenges to adaptation, mitigation. And SSP3 is a world with high challenges to adaptation and mitigation. And then using these characteristics of the SSPs and based on the building blocks of health systems, we developed some simple adaptation scenarios that we use to develop what are called the burning embers. These are in the summary for policymakers and in a couple places in the chapter in the AR6. And when you look at these figures, there's 4 of the 6 are here. The 0 line is pre-industrial. The gray bar is current increases in global mean surface temperature. The y-axis is increase in global mean surface temperature above pre-industrial. The dots are the level of confidence in the transitions. And the colors are white, that it's not possible scientifically to determine if, for example, on the left, heat-related morbidity and mortality has shifted. When the color turns to yellow, it means indeed that heat-related morbidity and mortality has changed. And there is at least medium confidence that some of that change is due to climate change. Red is high risk and purple is very high risk. And you can see that these are under 3 adaptation scenarios, the 3 I mentioned on the previous slide. And so hopefully the first thing that strikes you when you look at these figures is how important it is to both mitigate and adapt. That the faster we mitigate, the less we're going to have to adapt to. But if we don't actually make that investment in adaptation, we're going to have much more severe impacts in a much shorter time period where time and temperature are dependent on each other. Unfortunately, where we sit today is when you look at the adaptation funds under the United Nations Framework Convention on Climate Change, less than 0.5% is going to health. We're not making the investments we need to make. There is a very, very long list of effective adaptation options. I've highlighted just a couple of them here that we cover in detail in the AR6, where the core is strengthening the resilience of our health systems, improving access to potable water, doing more about mental health and extreme weather and climate events, and integrate adaptation into adaptation options for food, social protection, and other issues. I'll give an example of one kind of an adaptation option that is quite effective for decision makers. This was recently published from British Columbia. And you can see that the authors developed indicators for exposure to heat, sensitivity to heat, and the capacity to manage heat waves. And based on that, they mapped the communities in British Columbia that are at higher risk during a heat wave. And they did this not just for heat. They also did this for flooding and sea level rise, wildfire smoke, and ground level ozone. Ozone is because ozone's formed on clear cloudless days. The rate at which it's formed is temperature dependent. All else being equal, with higher temperatures, you have higher ozone. And importantly, they then overlaid those to identify the communities that are very high vulnerability for all of these hazards. And this provides the information decision makers need on where it's urgent and immediate they start taking action to build resilience, so that as the climate continues to change, that we won't continue to see increases in the impacts on human health and well-being. And there's lots of opportunities as we do this, as we adapt, as we mitigate, as we respond and recover from extreme events. This is an example of what happened in the British Virgin Islands after Hurricane Irma. Part of the hospital was destroyed, the photo on the left. And the photo on the right is the plan for redoing that hospital so that it will be resilient for the next hurricane. And we can make sure we take advantage of the unfortunate opportunities of more extreme weather and climate events to really move forward on sustainability and resilience. And I want to end with a couple of comments about mitigation. That when one looks at the major categories of mitigation, of reducing emissions from coal-fired power plants, from reducing vehicular travel, getting more people into electric vehicles as we can, but certainly reducing the number of internal combustion engines that are used for transport, and changing diets, because growing and consuming red meat results in lots of methane emissions, where methane is a major greenhouse gas. Each of those big categories of mitigation options have significant health benefits. When you count up the changes in population health, you count up the number of avoided premature deaths, the number of avoided hospitalizations, and you value those. The value of those health benefits are of the same order of magnitude, if not larger, than the costs of mitigation. We should be mitigating for our health. It will benefit the climate and benefit our environment, but primarily it will benefit our health. Here's one study that's an example from New Zealand, just shifting 5% of short urban car trips to bicycles. And you can see the numbers. Saving in fuel, deaths that you can save, and a big decrease in healthcare costs. So mitigation is equally as important as adaptation. We need to move forward. And as we do so, that's how we're going to protect the children of the future. About 85% of all the health risks of a changing climate are in children. And as we think about how to increase prosperity, we need to think about how we're going to protect these children into the future. Thank you very much. I appreciate you listening and look forward to your questions.
Thank you, Professor Ibai, for this interesting talk about global climate change and health. We have some time. We can take 1 or 2 questions. If anybody has questions, please, you can ask your question. Professor Ibai, you are in.
I never believed that I could be perfectly clear and that nobody has a question. So I hope somebody does have a question.
Sure, I'm happy to jump in.
Great.
Thank you very much for your talk. I actually had several thoughts and questions coming out of that, but I guess I just wanted to start with a little bit more of a general question. I'm just curious to know how we can actually elevate health in the climate debate. It seems to be always a kind of a secondary kind of aspect within the climate debate. And so I'm curious to know kind of your thoughts on how we can elevate health impacts in general.
Thank you. And it's something that the field has been working on for a couple of decades and has been making progress. Health is mentioned in the Paris Agreement, which was a great advance. And there were several programs rolled out by the World Health Organization at the last conference of the parties. But you're right, there's a lot of work that needs to be done to elevate health and to get the various adaptation funders and the research organizations to recognize that this is a critically important area. And the elevation has to be not just at the negotiations, but also at that research and implementation. there has been next to no investment from, for example, the National Institutes of Health has been funding climate change and health for a while at the rate of 0.02 to 0.04% of their budget. When antimicrobial resistance arose as an issue, they started out at, I think, 3% of their budget for AMR. So really no significant investment there. Similar numbers in many parts of the world, but Europe has really shifted. They're starting to fund in this area, which is really important. And increasing awareness, education, everything that we can do to make sure that this rises higher on the agenda will be helpful.
Great, thank you. I just want to remind all attendees then you can submit any questions that you may have using the Q&A button that is located at the bottom then of your Zoom screen. Are there any other questions?
So there's a question on mitigating the impacts of heat waves. So the major approach is developing heat action plans. And Maricopa County has done really a great job. When you look at heat action plans, there's two major elements. One is a heat wave early warning and response system. And that is not just having the broadcast meteorologists stand up and tell us it's hot, but actually having a plan of having cooling centers, of making sure you've got everybody you need at the table. You want to have, of course, EMT, but the fire department, the police department. Health is key to helping this coordination. Who are the trusted voices in the red line communities because they're hotter than the rest of the city? And so having a comprehensive heat action plan really makes a big difference. When you look at the heat waves in Europe in 2003, there were about 70,000 excess deaths. And 3 years later, there was a big heat wave in France, and there were a few thousand deaths, but nothing like what occurred in 2003. So we know that these work. The second part of your heat action plan is the long-term planning, looking at a hotter future. And what do we do about our infrastructure? Are you going to plant trees in the red line districts? Are you going to require every building to have a white roof, every building over a certain size to have a green roof? There's lots of work that can be done with our infrastructure to shift our infrastructure to be more livable in a hotter climate. And so lots of activities packed within that, but the basic is develop a heat action plan.
We have another question that's come in actually from Jim Beiser. I don't know if Jim can ask this directly. If not, I will just read the question. He says, hi, Chris, great to see you again. Drawing on your superb work from the 3 IPCC and the UNFCCC, have you seen evidence of governments around the world that are truly committed to finance solutions needed?
Yeah, thanks, Jim. And it's great to see you as well. I'll virtually see you as well. It's been a while. It's a really good question. And the answer is patchy, that there's some countries that are doing a really amazing job. Bangladesh is really taking the lead. Several years ago, it reframed itself from being the most vulnerable country to the most resilient country. Funding comes through and it all goes, I believe, to the Ministry of Finance. They have a committee that it goes to. And the country decides its priorities. So these are country-led instead of being donor-driven. And they make sure that the finance is going exactly where they need it. Doing monitoring, evaluation, making sure that they're spending that money wisely. So many countries are really thinking about how you reorganize yourself. Several countries now have a minister of climate change to make sure that they do focus appropriately on their needs and then work with the donors to get the money they need. Do we have enough? No. We're a long way away from having enough money for mitigation or for adaptation. And we're going to see what happens as we go forward with the Paris Agreement. The global stocktake is coming up. That'll tell us where we stand in terms of our needs versus the investments. And we'll be hearing more about that in the negotiations.
Thanks, Chris. So I have a quick question. Well, maybe it's not a quick question, but about the mental health impacts, which you touched on a little bit here. So, I think a lot of us are parents or grandparents and are trying to figure out how we communicate about climate change with our kids. Personally, I have had conversations, but they also overhear me talking in a professional capacity, and there's a lot of climate change anxiety and mental health stress that I see in my own kids and in other young adults that I talk to who just feel some despair. So do you have ideas or thoughts on how do we address this growing mental health problem that's really directly related to this sort of existential threat that people are feeling?
It's a really good question. And coming from the health sector, we do, in this case, really do have a unique perspective. There's lots of commonalities across all the sectors. And it's from healthcare itself. You don't want to go to your doctor and have the doctor not tell you that you've got a serious disease, that you expect honesty from your doctors. And so I think it's part of our role to be honest about what's going on. Not to dramatize, not to underplay, but this is the situation. And then in terms of how to manage this anxiety, a couple of interrelated responses. The first is, of course, about the Yale Six Americas program. And one of the real interesting questions they asked last time, I think the time before, so the current numbers are they do a survey every year of the US population. About 75% of the US population knows the climate is changing. 2/3 are pretty worried about it. Half of them think climate change is already affecting their health, which are not numbers you would expect if you listen to the mainstream media. But then they asked, do you talk to anybody about it? And only 1/3 of Americans are talking to each other about it. And so you're right, starting these conversations is really, really important. That people are worried, but they're not sharing their concerns. It's a little different on university campuses, but when you're not on a university campus, they're not sharing their concerns, which bottles it up. And the other is realize you're in the majority, that most Americans are feeling what you're feeling, and start finding ways to join with people for things you really care about. In King County, Seattle sits in King County, every other year we have the Green Globe Awards. It's to 12, 20 individuals, organizations that are working towards sustainability. And they're really inspiring. And finding these organizations that are doing such tremendous work and something that you want to engage in. And that will connect you with people who share the concerns, but also connect you with people that are doing something about it. Because every action matters. The more we work together towards resilience and sustainability, the faster we're going to get there. And the second thing I'd like to say is there's lots of discussion of transformation. It's always framed as something's going to happen in the future, which I think is really unfortunate. The transformation's happening now. And we need to recognize the transformation is underway. I was recently in an underground parking lot for one of our grocery stores, miles of cement down there. I'm carrying my groceries back to the car, and it sounded like wind chimes. And I actually stopped. I was trying to figure out why would there be wind chimes with all this concrete down there? And it took me a moment or three to realize I didn't hear an internal combustion engine. I heard all the electric vehicles because they tinkle at low speed to let you know. And when there's a whole bunch of them, it sounds a lot like wind chimes. And I stood there and thought, this is what it sounds like. This is what my grandchildren are going to grow up hearing. They're going to hear this in the underground parking garages. They're not going to hear all the stuff that I heard when I was smelt all the stuff I smelt when I was growing up. And so encouraging people to look around and see where there is already transformation underway. And that helps give people hope as well.
Yes. I'm sure there are a lot of questions there, but we are running out of time. So Thank you so much. Thank you, Christy, for interesting thoughts. And obviously, you worked in Bangladesh, and I'm from Bangladesh, so it's nice to hear good things about my country. And our next speaker is Dr. Robert Costanza. So Dr. Robert Costanza is a professor of ecological economics at the Institute for Global Prosperity at University College London. Professor Costanza is a global pioneer of transdisciplinary research at the complex intersection of dynamic human economic, social systems and stressed ecosystems. Costanza's transformative whole system approach integrates systems ecology, ecological economics, ecosystem services, ecological modeling, energy analysis, environmental policy, social traps and addiction, incentive structures and institutions. He is a co-founder and past president of the International Society for Ecological Economics and was founding chief editor of the Society's journal, Ecological Economics. He currently serves on the editorial board of 10 other international academic journals. So Professor Costanza is the author or co-author of over 600 scientific papers and 28 books. His work has been cited more than 133,000 times in Google Scholar with an H index of 134. More than 350 interviews and reports on his work have appeared in various popular media, and he has written over 75 articles for the popular press. I now request Professor Costanza to provide his speech. So please welcome Professor Robert Costanza.
Thank you. Thank you, Abu. And I'm going to go ahead and share my screen. Let's just make sure that you can all see this. So I want to talk about how to overcome our societal addiction to growth to create a sustainable well-being future, and focus on that as part of the reason that we haven't made as much progress as we should have over the last several decades. We've known about these problems for a long time. And we're getting more and more detail about how serious they are, but we haven't made as much progress as we would have liked. Why is that, and what can we do about it? We know that we now live in a whole new geologic epoch, the Anthropocene, where the magnitude of human impacts on all of our biophysical and ecological phenomena are significant, much more significant than at any period in the past. So business as usual is no longer an option. I think if we really want to create a sustainable and desirable Anthropocene, we're going to have to think and act quite differently. And we have to make it a transformation that's already been talked about to an economy that's based on a whole different goal, to get away from the goal of mindless pursuit of GDP growth and toward one of building a sustainable well-being of humans and the rest of nature, recognizing that we are intimately interconnected with the rest of nature. It's not people over on one side and nature on the other. It's really a complex interdependent system. And I think that's the change in vision. Really, that's kind of a precursor to allowing us to solve some of these problems. So to achieve sustainable well-being, we have to have an adequate vision, first of all, of how the world works. I think we're developing a much more comprehensive vision of that. From our work in earth system science and climate science, but also in psychology, and particularly positive psychology. What actually does contribute to sustainable well-being, and it's much more than simply the consumption of goods and services. It's about security. It's about social relationships. It's about ecosystem services and the things that nature provides. So we need to take a much more integrated understanding of the world, but we also need a more adequate vision of how we would like the world to be. What's our vision for the future? And how can we use that to motivate the kind of changes that we need to achieve that vision? But developing that shared vision, I think, is a key element. It's also going to take tools and analytical techniques that are more integrated with that that emerging vision and understanding of the world. And I think that's going to take more systems thinking, more modeling at these larger interconnected scales, more transdisciplinary work, and implementation strategies that involve probably new kinds of institutions that can manage our common property assets better, and institutions that can maybe help with the societal therapy that we need to overcome this addiction. So we know that there are fundamental ecological constraints to human activity on the planet. You've probably seen some version of this planetary boundaries paper that Johan Rockström and Will Steffen and several others have been doing going back to 2009. There's several new versions of this, but obviously climate change, biodiversity loss, and the nitrogen and other material cycles are probably well beyond the safe operating space, as it's been called, for the planet. So we're not behaving in a biophysically sustainable way. We know that the world is a complex, nonlinear, adaptive system. There are thresholds, there are tipping points, there are surprises. It's not going to behave in a nice, smooth way. And this is just a list of some of the potential climate tipping points that are out there, including the ice sheets melting, but also including a whole range of other kinds of phenomena, the changing El Nino, the dieback in the Amazon rainforest, et cetera. All of these things could have quite rapid and more rapid than some of the models are predicting changes in the climate and in our sustainable well-being and health. Unfortunately, this is not the movie that many people are lining up to go see, especially outside of academia. They would rather believe in some of the reassuring lies that things are not as bad, perhaps, as they really are. So how do we break out of this addiction? Well, I think we need a third movie. We need a movie that's a new vision, a new narrative describes what a sustainable and desirable economy in society, in the rest of nature, could look like in different parts of the world, and how that sort of world would be much better than the one we currently live in, and certainly much, much better than the one that we seem to be headed towards, and it's causing all of the despair that was mentioned earlier. So we need to stay within planetary boundaries for sure, but we need to create the elements of well-being and quality of life that will support that human well-being going forward, and the well-being of the rest of the planet. So we need to stay in what Kate Raworth has called the donut. We need a whole new vision of what the economy is and what it's for. And I think that's what ecological economics has been about since its creation, around these three integrated questions or goals of maintaining an ecologically sustainable scale, or staying within planetary boundaries, creating a socially fair distribution. All these issues of inequity are certainly huge, and that fair distribution needs to be both within the current generation of humans, but also between the current and future generations, and also between humans and other species. How do we really distribute wealth and resources equitably and fairly? And finally, how do we allocate resources more efficiently, but including everything that contributes to our well-being, not just things that are allocated by the market, but things that are outside the market and should stay there, like our natural and social capital assets. We still need to value them and allocate them efficiently. So understanding these contributions to sustainable well-being, I think, involves understanding how these four major types of assets interact to produce that well-being. And that includes our built capital assets, or conventional economic capital, also our human capital, individual people, but including all of their health and education and innovation, and our social capital, all of the interactions among individuals, our cultures, our governance systems, our formal and informal networks, and finally our natural capital, everything else in the world that humans didn't have to create, but that are essential in producing this sustainable well-being. So this is obviously a complex and very transdisciplinary kind of study to understand all of those contributions and how we balance them out. Many years ago now, back in 1997, we tried to estimate the contribution of natural capital and ecosystem services to human well-being, and expressed that in monetary units. And we came up with an estimate, a conservative estimate by all accounts, but still something that was much larger than global GDP at the time. One thing we didn't control was what they put on the cover of the magazine. We did make the cover, but they said pricing the planet. We didn't really mean pricing. We meant valuing the planet and recognizing the distinction between marketable commodities and goods and services that are rival and excludable and can be traded in markets, and what we're really talking about here, which was public goods like natural capital and social capital, but can still be valued, and it's important to recognize those values so that they don't get ignored. We have to make them more visible. We more recently estimated how those values were changing since 1997 up until 2011 in this case, and came up with estimates that were in the range of $4 to $20 trillion a year of losses of ecosystem services, largely because of land use change and degradation, and desertification, loss of coral reefs, loss of wetlands, et cetera, were very important in losing some of the value of these services and the biodiversity that they contain. And it's also important to look into the future and consider different scenarios about what could happen. How can we turn this around? And these are based on the Great Transition Initiative scenarios, but I think that they're sort of archetypical of many that have been done. If we continue on our current path, business as usual and market forces, things continue to get worse in terms of ecosystem services. We can sort of halt the loss, or we can make a great transition and transformation where we begin to rebuild those ecosystems, replant forests, reclaim wetlands, et cetera, and really start to recover the value of many of those ecosystem services. We also know that we've been following the wrong guidelines in terms of GDP, and this is a relatively old plot, but I think this hasn't changed much. If you plot GDP per capita on this axis versus life satisfaction, what people say, how satisfied they are with their lives, you generally get this sort of diminishing returns kind of curve, that beyond a certain point, around $10,000 or so dollars per person per year, you're not really improving life satisfaction by very much, even though you're spending a lot more and you're causing a lot of the negative side effects that GDP is currently having in the Anthropocene. We know that GDP was never designed as a measure of societal well-being. This is a quote from Simon Kuznets, one of the architects of GDP, emphasizing that you can't determine the welfare of a nation simply by measuring its income. If you want to talk about growth, you got to talk about growth of what and for what. And in fact, what we want these days is growth or improvement of sustainable well-being. We don't necessarily want continued growth of consumption and production, particularly in the wealthy countries. But we do need to better allocate and better distribute the production and consumption so that everyone has enough in a more secure way. Back in 1968, Robert Kennedy made a famous quote that, and recognition that the country's gross domestic product measures everything except that which makes life worthwhile. It's a very limited estimate that's only measuring the marketed economic transactions, things that are traded in markets. So it's well past time to leave GDP behind, as we said in this commentary several years ago. And there's a large number of indicators really that people have proposed as alternatives to GDP. I'll just talk about one that's been used and I think has some interesting results, called the Genuine Progress Indicator, that starts with personal consumption, which is a major component of GDP. So people do need to eat, they need all of the things that GDP is measuring, but it then weights that by income distribution. Because if you're talking about welfare instead of just income, you've got to talk about how that income is distributed. So these equity concerns are built in. It adds a few things that are left out of GDP, like the value of household labor and volunteer work, things that are very important to people's well-being, but are not marketed. And then it subtracts a bunch of things that should not be counted as positives, even though they are in GDP accounting. The cost of crime, if there's more crime, there's more police, there's more security devices, that's going to get added to economic activity, but it's not a good thing, it's a bad thing. And a whole bunch of natural capital components, the cost of air and water pollution, noise pollution, et cetera. The interesting thing about this is what happens when you apply this to many countries. And it's been done for, I don't know, in this case, we use 17 major countries for which this index has been estimated and tried to come up with a global total. And in that case, GDP per capita, the green line here, keeps going up over that time period out to 2005 in this case. But GPI per capita leveled off and started declining about 1980 or so. So after this point, we're in a period, after 1980, we're in a period of uneconomic growth. The economy is growing. It's not really improving well-being though, or welfare. But it is because of these negative side effects, because of growing inequality, which really started getting worse in 1980-ish or so, and climate change and other damages to the natural capital. So our goal, if our goal is to create a sustainable well-being economy, I think we have to break this addiction to the growth at all costs paradigm, to fossil fuels in particular, and to overconsumption in at least the high-income countries. How do we do that? I think a key step in the therapy is to build this shared vision of what kind of world that we really want. Why do we think that's a step in the therapy? Well, we published a paper recently looking at what seems to work at the individual scale to overcome addictions and what we might learn from that, from those individual therapies. We know that at the individual scale, the worst thing you can say to an addict is you're doing the wrong thing, you got to stop doing it. That usually gets a very defensive kind of denial reaction. But there is a therapy called motivational interviewing, which seems to be quite effective. And instead of confronting addicts directly, it starts by engaging them in a positive discussion of their goals, their motives, their futures, what kind of life do they want for themselves. And then that, once you've established that, you can go back and say, well, how, if if that's the kind of life you want, is what you're doing now really helping you get there or not? The obvious analogy at the societal scale is how do we engage the whole society in discussing our vision, our goals, what kind of world do we really want? As the famous American baseball player and philosopher Yogi Berra once said, if you don't know where you're going, you end up somewhere else. We have to have a clearer vision of what we're trying to achieve. The UN Sustainable Development Goals process, I think, is a major step in that direction. It's the first time in human history, really, that all countries in the world have come together and agreed on a set of shared goals. These are displayed as independent goals. And in fact, there are many trade-offs and synergies and interactions among them. But I think they do cover all of the things that are important to people's well-being and to nature's well-being, or the rest of nature's well-being, in terms of urgent action on climate, protecting marine and terrestrial resources and ecosystems and natural capital, better governance, et cetera. I'm sure you've all seen versions of this, but I don't think the general public has even heard the term Sustainable Development Goals, many of them. So I think our challenge is really how to engage a broader population in that discussion of the kind of world that we want to create. We published a book recently with a series of essays along those lines, asking authors to tell us what they thought this world could look like, and also how we might get there. There's been a lot of work internationally on scenarios and scenario planning. The IPCC certainly uses scenarios. This is from the Great Transition Initiative set of scenarios. They do tend to fall into these sort of archetypical categories: a business as usual scenario, a sort of policy reform type scenario, a great transition scenario. How do we recognize that we're all in this together? We need governance at many levels. We need more stewardship and sharing. We need to focus more on the community versus just individuals. We need to focus more on a broader definition of well-being rather than just GDP growth. So, and I think the SDGs sort of fit into that great transition group of scenarios anyway. But the challenge, I think, is, again, communicating those alternative futures and getting people to recognize that there are alternatives and that the choices we make now can help us to achieve a much better world. We're not constrained to end up in one of these futures if we can make the appropriate choices. But I think as part of the therapy, we need to really build a shared vision about what those visions look like. And I think that's a challenge going forward, and that to communicate those visions and get some feedback. We tried one thing in Australia where we did a public opinion survey for these 4 scenarios. We changed the names and made them more specific to Australia, but essentially similar to the Great Transition scenarios, calling it by different names just to recognize that the ones in the Great Transition are maybe a little value laden. So instead of fortress world, we said strong individualism, community well-being instead of the Great Transition. Anyway, we had people then read about what these futures look like and then take a survey and tell us which ones did they prefer. And by far the community well-being scenario ranked 72% ranked it as number 1 or number 2 in terms of their preferred future. We also asked them where they thought the country was headed. And they most of them said they thought it was headed to the free enterprise, business as usual sort of scenario. So people really want, I think, a different world, but they also, I think, are in despair that we're not headed in that direction. How do we change that? There was also the question of, well, is it possible even? Is it feasible? Can we create an economy that's not growing, that's still producing all of the things that we want? And there are a couple of recent books, Peter Victor's Managing Without Growth and Tim Jackson's Prosperity Without Growth. Peter did a macroeconomic model of the Canadian economy and tried to answer that question directly. And he said, well, yes, you could have a no growth disaster if we just stopped GDP and didn't do anything else. But we could also produce a better low or no growth economy if we take the appropriate actions now. So you could think of this as part of the therapy. What's the 12-step program that we need in order to achieve this steady state, sustainable well-being kind of economy? First of all, we need new meanings and measures of success. We need something like GPI, something that measures well-being more directly and not just GDP. We need limits on materials, energy, waste, and land use change. Obviously, we need more meaningful prices. The market's not telling us the truth about the true cost of everything that we buy because it's leaving out the external costs, the damages to the natural and the social environment. We need more durable and repairable products. We don't need to waste energy producing things that just wear out. We need fewer status goods and more things that benefit the community well-being, more informative advertising. Advertising is trying to tell us we're unhappy because we're not consuming more. But we need advertising that just tells us what products do. Better screening of technology. Technology is a good servant, but a poor master. We need to not just follow wherever the technology leads, but tell us what kind of technology we really need. More efficient capital stock, more local, less global. We're certainly seeing that as part of the COVID pandemic. But I think this has to do much more with building local communities and the well-being that enhances in terms of social capital and preserving natural capital. That we don't really need to move things around any more than we have to. Reduced inequality, we talked about that already, and the reasons for the need to really reduce inequality significantly. Less work, more leisure. We need to reduce working hours. We need to give people a better work-life balance, et cetera, if we really want to improve their well-being. And finally, we need to educate people for life and not just for work. So it's about encouraging people to learn about what does contribute to their well-being and how they can achieve that, not just to educate them to get a job, to make money, to buy more stuff that they don't really need. Anyway, I think we also need to change our institutional structures to be able to manage our common assets, our natural and our social capital more effectively. And so we've been working on developing this idea of common asset trusts that can steward these natural capital resources. This is based on the work of Elinor Ostrom, who who got the Nobel Prize in economics for her work on how to manage commons sustainably and well. And she has a set of design principles that I think can be followed in designing a whole new sets of institutions that manage commons without leaving them as open access resources or privatizing them through private goods. We can manage them effectively as commons, and there's certainly much of the world, including the atmosphere, including the oceans in particular, that can be thought of more effectively as common assets to be held in trust for current and future generations. And then we can design financial mechanisms and institutions around that. And finally, I think we need to bring together all of the groups that are working towards these shared goals. And I don't know if you've heard of this, but there's something called the Wellbeing Economy Alliance that's been constructed and established that tries to do just that. And part of that includes a few vanguard governments that have taken on this agenda of building a well-being economy, in particular being led by Nicola Sturgeon, the First Minister of Scotland. And I encourage you to take a look at the TED Talk that she did a little bit ago, explaining why it's so important for governments to start thinking of themselves as creating a well-being economy and not simply a GDP-based economy. Certainly, New Zealand has been moving more in that direction, and as you probably heard about, more recently, Iceland has also joined there, and Finland. So the well-being governments currently include those three, plus Wales has also joined, and I think Canada has recently joined this well-being economy government group. So you might think, in the future, we might have a meeting of the We7 or the We20 instead of the G7 or the G20, and hopefully to get all governments involved and all individuals and all institutions involved in heading the economy and the society more towards sustainable well-being. So take a look at the Wellbeing Economy website. And I think it's time to really take advantage of some of the crises that are going on right now to build back better, to take the initiative to really move toward the kind of world that I think we all want. And hopefully we can get there in the not too distant future. Thank you.
Thank you very much, Professor Costanza, for really very informative and thought-provoking speech. We can have a few questions. If you have any question, you can write to the Q&A. But right now we have a question from Dr. Soto that what lessons have been learned from the new classical economic model? For example, many market failures, both in practice and theory. And do you view the field of economics as perhaps adapting or evolving in response to the current challenges and threats?
That would be great if they were adapting and evolving. I think that should be happening much more quickly than it has over the last several decades. But of course, there is some movement. I mean, the fact that Elinor Ostrom was awarded the Nobel Prize in economics, Daniel Kahneman was awarded the Nobel Prize in economics, people that were not in the sort of mainstream economics view. And I think that there are just a few fundamental assumptions that need to change about how the economy works, what the economy is, and what it's for. And I think hopefully that is changing. Recognizing that the goal of the economy is not simply to produce more stuff. The goal of the economy is really, or it should be, to produce sustainable well-being. And I think there's growing recognition about that. There's also growing recognition that people don't behave the way the conventional economic model assumed, at least in the not too distant past. People are not just individuals unconnected from the rest of society, just pursuing their own narrow self-interest. They are really humans have always been parts of groups and cultures and societies, and that's what contributes to our well-being, but also contributes to our success as a species. So incorporating all of the things that that I talked about, I think is going to be necessary for economics to be relevant and useful in this transition.
Yeah, thank you. So if there is no other question, we can move to the next speaker. And obviously, if you have questions, we are having panel discussion where Professor Costanza will be there. So you have more chance to discuss for other aspects as well. So our next speaker is Dr. Donald Falk. Dr. Falk is a professor in the School of Natural Resources and the Environment at the University of Arizona. His research focuses on biohistory, bioecology, and the adaptation of restoration ecology to resilience in a changing world. He is a fellow of American Association. Excuse me. He is a fellow of American Association of the Advancement of Science, and has received a Fulbright Short-Term Scholar Award and the Ecological Society of America's Davy Award, and the Udall Faculty Fellowship in Public Policy. Dr. Falk was a delegate to the 2015 United Nations Climate Summit in Paris and leads the University of Arizona's undergraduate degree program in global change ecology. And Management. He was co-founder and executive director of the Center for Plant Conservation, originally at the Arnold Arboretum of Harvard University and now at the San Diego Zoo Global. He is the author of more than 150 publications and including 5 edited books. I now request Professor Falk to provide his speech. So please welcome Professor Donald Falk.
Thank you so much, and I want to say what a privilege it is to share this webinar with these 2 very distinguished and deeply insightful colleagues. I'm going to step off to a slightly different angle and look at some of the same questions that Dr. Eby and Dr. Costanza have looked like, and that is from the perspective of ecosystems and what their dynamics look like in a rapidly changing world. I want to begin with an acknowledgement about the land that we work on and that we live on. In North America and elsewhere, this is largely land that was colonized and unceded by the many indigenous peoples who have lived here for many thousands of years. And this is relevant because we're discovering increasingly that their practices were in fact had a great deal to do with what made these landscapes resilient in the way that we are learning to define them now. If you had bought stock in the word resilience maybe a decade ago, you'd be rich by now. The problem is that it means something different in almost every different context. And even just this morning, we've heard it used in different ways. This is not necessarily a bad thing. It just means that it's a contextual word. And I'm going to talk about resilience from the perspective of ecosystems. And as you'll see, I think the dynamics of a resilient ecosystem are somewhat different from what we might see in human communities, although there are interesting similarities. And I would encourage you to just think about what resilience means to you and how you might define that. In the area of ecology, we're trying to build a model of ecological resilience. This is something we don't have yet. And the primary reason being that we can see the emergent properties, that is the results of the phenomena of resilience. We have very limited understanding of the mechanisms that actually make ecosystems resilient. And this is complicated by the fact that ecosystems are really not stable entities over space and time. They're changing anyway, and so how can we distinguish the kinds of background variability that are inherent in ecosystems from something that would fall into a category of resilience? This means, importantly, that the idea of an undisturbed ecosystem is a null concept that really doesn't apply. If we think of ecosystems as systems that are always in change, we've got to map the process of resilience onto a moving target to begin with. So can we do this? Can we define resilience without making this assumption that ecosystems are in fact stable? Well, in North America, a great example of this would be just to look at the forests that we see in the landscape, most of which are between 500 and 600 years. There are a few exceptions that prove the rule. Some of these notably ancient ecosystems like the bristlecone pine in the White Mountains and elsewhere in the West. But the vast majority of forests turn over, and I say aperiodically, but pretty widespread turnover in forested ecosystems from fire, insects, and disease. And in fact, when we map this out in time, we can see that most of the forests that we are surrounded by originated during the Little Ice Age. That gives them a time stamp. It also gives them a genetic stamp and an adaptation to the conditions during which they originated, which are very different from the climate conditions in which they're having to adapt now. This suggests a starting point that is very different from the conditions that they would be adapting to. But it's also important to recognize that this kind of long-term adaptation to climate variability is in fact not only well documented, but it's an essential part of how ecosystems work. So as we try to map the rates of projected change in climate and the shifting biomes geographically, this climate velocity in some cases matches what species and communities have experienced before. In other cases, it's going too fast for them, and this is where resilience starts to be reflected in ecosystem stress. So the question we have before us, both in terms of ecosystem function and also in terms of the essential services that Dr. Costanza referred to earlier, is how will ecosystems recover and adapt to this period of rapid change? We have an emerging framework that pulls all this together, and I won't go into this in detail. It's a recently published TAM review, but you can see over on the left side that there are some cases where an ecosystem represented iconically by a forest here is exposed to some kind of disturbance, and in some cases that's within its ability to persist. In other cases, the disturbance exceeds those survival parameters, and we end up with an episode of mortality. It's important to say these could be from climate-only stress, for example, drought or temperature extremes, as well as wildfire, insects, or disease. In some cases, that episode of mortality, which we're seeing increasing evidence about, is followed by a recovery, and we essentially loop back to the original state of the system. And that's something that for land managers and most of the public, we feel is a good outcome. Sometimes those loops are a little bit longer. We can go through what's called a transient reorganization. And here we have to remind ourselves that ecosystems work on timescales that are very different from our limited short-term attention, maybe 100 years to get back to a starting point, an ecological starting point, following some kinds of disturbance, such as aspen recolonization following major wildfire. But increasingly, we're seeing alternative outcomes represented here by icons for different tree species, shrubs, grasses, just as examples in terrestrial ecosystems in North America that we're seeing. And these alternative states are very interesting. They're very widespread, and they really are the crux of the resilience problem, as I hope to show you. So what do we actually observe for the ability of ecosystems to be resilient under these very stressful conditions of temperature and drought and wildfire and other stressors? Well, as I showed you in the previous diagram, the very widespread response, and in many ways the response that provides us with the highest continuity with the pre-disturbance community, is persistence. That is when the individual can actually persist through those stressors. A good icon for this would be giant sequoia. These are individual trees with names. That's fairly unusual in the plant world. But these are individuals where we monitor and watch the persistence at the scale of an individual, much like we might monitor and watch the persistence and survivorship of a person in our social circle whom we care about. These mechanisms of persistence are highly evolved. They represent millions of years of biological evolution, and they indicate the ability to tolerate drought, climate, and fire, as well as other components of the evolutionary environment. So this doesn't happen by accident. This is an evolutionary investment in persistence. And there are a lot of ways to persist. You don't simply have to tough it out in the way that we might imagine our own bodies surviving stress. Many organisms, such as the ones shown here, oaks, eucalypts in Australia, Chihuahua pine on the right, can resprout even after being top killed. And so we have to think about plants having a much wider range of persistent strategies from simply the ones that we might identify. But eventually persistence breaks down, as we showed originally, when that disturbance stress is too intense. Then there is mortality, and we have to rebuild now at the population level because the adults have been killed. Recovery depends on entirely different mechanisms for at the population level from what we see in persistence. And this, again, can be a rapid process. We can see recovery happening within a year or two, say in a burned grassland, or maybe over a century or more for forest recovery under more severe conditions. Again, there are many, many strategies for recovery. In the case of forests, many forests will recover by dispersing seeds into burned areas, as you can see in these panels here. But the problem with recovery processes is they can also fail. They can be pushed beyond a threshold. And a good example of this would be the very large wildfires that we're seeing increasingly with very large contiguous high severity patches. This is a fire severity map for the 2011 Las Conchas fire, which burned about a third of that very large mountain range within a matter of weeks. And you can see the large red areas, which are areas of essentially complete tree mortality and complete soil loss. The problem with high severity effects like this, and we see this incidentally in large areas affected by drought and insects, is that seeds from surrounding areas can't reach into those areas. Seeds can only reach a couple of 100 meters every 30 years, that is every generation of trees. And so it can actually literally take centuries for recovery to reach the center of these large high severity patches. And once the seed arrives, it's got to find suitable sites for germination, free of competition. So the recovery process is really fraught, and in many cases is being pushed beyond its success by climate conditions that are being encountered currently. So when these two processes, that is the ability to persist or tolerate stress and the ability to recover from it, fail, we then move into the third, and I think the most important area for us to understand, and this is reorganization. And this is where resilience in an ecosystem is very different from resilience in our own bodies, because we have a homeostatic understanding of human health. Ecosystems are not homeostatic. They are always changing, and they're always adapting, and they're shuffling their parts around. And so we see this kind of outcome increasingly. Here we have 4 post-fire landscapes in the upper left, a post-fire landscape colonized by ferns, in the right by grasses, in the lower right, different species of trees, the lower left by post-fire shrubs. What I want to emphasize is that once again, this outcome is entirely the result of biological evolution. These species are playing exactly the role that they have evolved to play. And so here now we are no longer at the level of the individual or the population. We are involved in what are called community assembly processes. That is the reassembling of novel communities from whatever parts may exist around the landscape. These, I think, are the crux of the resilience question, because first we have to ask, are these simply transient states on the way back home to where we started, or are these going to persist? And second, are these altered states possibly, in some cases, better adapted to future conditions? I think you can see that the answer to these questions is extremely consequential. If these are persistent alternative states, then we are looking at massive ecological reorganization on a global scale, and I'll show you some evidence that this may be happening. But if these systems are also better adapted to future conditions, and in particular better adapted to the nexus of climate, wildfire, insects, and disease, then it's possible that these altered ecosystems may in some cases be a pathway to continued provision of ecosystem services, albeit at reduced levels, for particularly carbon sequestration, compared to the pre-disturbance state. So these are very difficult and challenging and new questions that we need to understand. You can see then that this means, to put this in other terms, is reorganization, this transition, is this an expression of ecosystem resilience because it relies entirely on the evolutionary ecology of these species and communities? Or is this a failure of resilience? Is this over the line into collapse? There's no simple answer to that question, but I want to provide you some evidence on these points. We recently concluded a project with land managers in the southwestern United States where we brought them together in a series of meetings and asked them if they are seeing evidence of type conversion. And we thought we might get a couple of dozen examples. We received hundreds. This is being widely observed by land managers, who, by the way, are very, very keen observers and should always be part of our research agenda. They see what is happening on the landscape often long before scientists have picked up on that. So the icons on this panel on the left from a paper that's in press just indicate some of those in situ observations of ecosystem reorganization or transition. And the panels on the right show for California and the southwestern states what those directions are going. And if you're not familiar with these core diagrams, these kind of indicate a starting point and a trajectory of change. And so you can see, for example, by far the dominant ecosystem change trajectory in California is from forest to shrubland, and in some cases from chaparral to non-native grassland as those systems become invaded. And very similar patterns here in the Southwest, where both dry forest and ponderosa pine are being lost and replaced by shrubland. So this is empirical evidence of this very widespread pattern of transition. I mentioned the mechanistic understanding earlier and how important that is. We're really just at the very beginning of understanding the mechanisms that drive these transitions and lock them into place. So you can see here, zooming in on that pre-disturbance state and then those stages we saw earlier: mortality, failure to recover, reassembly of the community, and creation of an alternative ecological state. And these are mediated initially by some kind of trigger event. Again, a heat wave, an extended drought, a severe insect outbreak, a severe wildfire, complicated by the synergy of climate and disturbance. Once you have a mortality episode and recovery failure, you then reassemble into an alternative state. And the important thing about the alternative state is now those same processes that were trigger events for change initially, climate and disturbance, become reinforcing events for the alternative state. And I'll show you a couple of examples of this. So this reinforcing property is one of the most important reasons why these alternative states are going to be so persistent and in fact so resilient. There are many examples of this here in the Southwest. We're seeing bufflegrass invading Sonoran Desert. In the Great Basin, we see cheatgrass invading sage steppe. And what happens then once you've created a new fuel bed is you've modified the fire regime, which is the critical reinforcing factor, from a sage or a desert fire regime to a grass fire regime. Grasses and fire love each other. It's a 10 million year old love affair. And so once you've switched into a grass fire regime, you've created a positive feedback loop, essentially a self-reinforcing system. And in the terms of ecosystem resilience, this is a very resilient system. It may not be desirable from our perspective, either ecologically or in terms of services that we expect out of these systems, but it meets every definition of a resilient system. And this is one way of modifying our use of the term resilient. There are many, many cases where systems are resilient in highly undesirable configurations. I mentioned earlier the importance of a mortality episode as setting the stage, creating open ecological resources, which then set the stage for ecological reorganization. This is a recent paper by Hammond and colleagues, including Dave Brashears here at the University of Arizona, showing increasingly the evidence for widespread mortality across biomes and across climate space, temperature, and precipitation. And on the right, you can see that the climate signal for those mortality years is actually accelerating faster than the climate signal for all years. This is using the Tmax, that is the maximum temperature signal. During the mortality years, that signal is accelerating. This suggests that climate stress toward mortality, climate acting alone, never mind being complicated by disturbance, is likely to become increasingly widespread. An example of why this matters, this is hands and knees ecology, but this is where we have to look, is the difference between what it takes for a population to persist through climate stress and what it takes to recover after there's been mortality. So this is called a climate space diagram, where we look at, in this case, growing season water potential and growing season temperature. And this large polygon would be the persistence space of established individuals. So think of a big overstory tree, a big 200 or 300-year-old tree that can live through climate variability from year to year. We see that expressed in the variation in tree ring growth. Seedlings have a very much smaller recruitment space, and it's not randomly placed within the persistence climate space of individuals. You'll notice that it's down here in the cooler, wetter corner of what a species can tolerate. This is very, very characteristic. Seedlings don't have the resources to tough out during a long, extended bad season or several bad years. Seedlings are simply going to die. Well, when climate is within its range of typical variability, you get years that satisfy that climate niche space, and you can have successful colonization. But the problem is the climate is moving in the other direction. Climate is moving drier and hotter, as we all know. This is a physiological prediction of widespread recruitment failure, and therefore the failure of recovery of existing ecosystems. This is often expressed then in bioclimatic envelope models of where species can adapt and can move geographically, assuming conservation of the niche space. And the important thing to see about these diagrams is that there is a trailing edge and there's a leading edge effect. So these are potential climate refugia, another new paper by Sandra Hare and colleagues, looking at several pine species in the southwestern United States and northern Mexico. So the US-Mexico border would go pretty much right through the middle of these diagrams. But what you can see is that to the trailing edge, the amount of available suitable habitat is declining, and it's advancing on the leading edge. The reason it's trailing is that although species can persist in those hotter, drier climates at the south end of the range, in fact, we have a failure of recruitment. There is no recovery. So the population is no longer replacing. You have essentially a relictual population with no reproduction. Eventually, it's going to die out. And that recovery process needs to be shifted ahead to the leading edge of the range. This is, again, that natural process that we looked at the very beginning of this presentation with species movement over time and space. The problem is the question whether species can actually get there fast enough to survive. As I mentioned, another dilemma of these alternative states, and again, many of these are comprised of native species, leaving aside the invasive grasses as a separate problem. But many of these alternative communities reconstruct themselves using native species, many of which are highly adapted to future climate and disturbance. Here in the Southwest, Gamble Oak is an example of this, where it's very, very persistent and very adaptable to coming conditions. So we have to ask ourselves, do we want to plow up all this Gamble Oak that is replacing post-fire stands of, say, conifers, and try to force the system back into growing the kind of community that originated during the Little Ice Age? Or do we have to accept that this is an ecological future and learn to live with it? There is no easy answer to this question, but this is obviously both an ecological and a valued question. I mentioned the word resilience and how widely it's used. This is my first and probably last paper in a peer-reviewed law journal, but I looked at the use of the word resilience in a wide range of government planning documents in the Forest Service and National Park Service. And what I can tell you is that the word resilience is used in the most limited possible sense in these documents, if it's defined at all, and most of the time it's not. When it's defined at all, resilience here means only persistence or recovery back to the pre-disturbance state. That's great when we can achieve it, but as I hope I've persuaded you, climate and disturbance are pushing ecosystems into a new space where that return to the pre-existing condition is unlikely and in some cases possibly not even desirable. Luckily, in the management community, there's a lot of good thinking going on. There are several frameworks that are adapting our mechanisms of resilience framework into land management protocols. But again, you can see at a certain point that you reach a point where you have an altered ecosystem going into a transition, and there's very little guidance for managers, and certainly there's not clear that there's social or political will to accept massive conversion of ecosystems into alternative states, and yet that's where we're going. So this is a really uncharted territory for both ecology and land management. I want to thank a number of people who have contributed ideas to this, and I'd be happy to take any of your questions. Thank you.
Thank you, Professor Falk, for a very interesting and informative talk. And if you have any question, you can write to the Q&A, and we can take your questions before we start to the transition to the panel discussion.
I see Bob has his hands up. Go ahead, Bob.
Yeah. Hi, thanks. That was a great presentation. I really enjoyed that. And I think in particular, your point that we can't continue to manage ecosystems in a way that assumes we're going to keep them the way they used to be at some, or try to get them back to the way they used to be at some arbitrary point in the past. So going forward, though, I think we need some sort of way to guide that restoration process that recognizes the complexity of the system. Do you think the ideas around ecosystem health and ecosystem services can help to guide that process, that recognize how the conditions are changing and recognize that novel ecosystems are going to appear regardless, but how do we make them as beneficial, to us and to the rest of nature as we can? Is that a way forward?
Yes, so absolutely. We need sideboards on these processes. We need to be able to define what kinds of change are acceptable and what kinds of change go outside of that. So for example, most people would view a system that's been completely invaded by a non-native species, and the grasses are an example. Melaleuca invasion in Florida is another example that's completely transforming those landscapes with a pyrophilic species. Those clearly would fall outside almost any definition, I think, of an acceptable outcome. But there's a wide range of operating space inside that, and we have to ask ourselves a number of very difficult and honestly very painful questions. I think any of us who are involved in biodiversity conservation and ecological studies, this is a very painful time. It's very difficult for us to face up to the fact that this change is happening, whether we like it or not. And so the best we can do is guide that within some of these sideboards. Absolutely, the essential ecosystem services that you describe in your work and that have been described elsewhere would be one set of criteria. I would say we have to be careful to balance the way ecosystems work for themselves and the way they work in provisioning services for humans. For example, there are some arguments for massive creation of carbon plantations, single species carbon plantations. And nobody really thinks that's a good ecological outcome. It seems like a kind of emergency carbon sequestration strategy. But clearly, we have to find some resonance between the services provisioning and ecosystems working on their own without regard to us. And it may be that that operating space is becoming increasingly limited because we have limited options for keeping ecosystems, native, wild, unmodified ecosystems anywhere in the planet. That's an increasingly shrinking space. But absolutely, we need some constructive dialogue here among these different strategies and find space that we can operate in.
Well, that's the problem with the Anthropocene, is there are no places on the planet that are not that are not impacted by human activity. So I think the sooner we recognize that and begin to manage the planet in a way that benefits the whole system, rather than trying to wall off part of it and say, anything that has any human impact should be protected away. Yeah.
And absolutely. And let me just comment that the kinds of strategies you laid out in your presentation, of course, would be one way to alleviate some of that pressure on the remaining natural ecosystems. Thank you.
And carbon forests are not maximizing ecosystem services.
Yeah, no, nor do palm oil plantations. Right. No. I think there is a lot of synergy here. We don't want to reduce this to simple one-dimensional metrics. We know that's not going to work.
Thank you.
Yeah, thank you.
Don, I have a quick question before we head to break. Excellent talk. I was curious to know, in terms of how does ecological management, adaptive management, then kind of fit in then to your resiliency kind of understanding, right? And so you kind of presented several different steps in terms of kind of assessing how resilient then a system is. Curious to know how then adaptive management then can kind of fit in terms of each of these different steps.
Yeah. Yes. Thanks. Right. Thanks for that question. So in general, I think we could say that the stages that involve persistence of existing conditions and recovery back to those conditions, that's a very comfortable space for land management. And we know how to do most of that, including we know how to offset the occurrence of severe fire behavior. We don't do enough of it, but we know what to do in that part of the space. And we can certainly learn how to do that better adaptively. The problem of mapping an adaptive model onto ecosystem reorganization is that we don't know where we're going or why, or whether it's good or bad. That's a very unusual space for land managers to be in. So a small scale example of that, for example, are the moves for assisted colonization, that is, assisting species in moving geographically across the landscape, assuming niche conservation. It's not that long ago that was considered a kind of heretical meddling with ecosystem processes. It's now become pretty mainstream, although it's not that widely practiced, but it is understood as one thing that we can do constructively and adaptively to help ecosystems make these transitions. But for the bigger questions, this self-reinforcing characteristic of alternative states and disturbance regimes and climate, the problem with adaptive management is that we're sailing really into a fog. And so what land managers are doing are experiments. And again, it's not clear that we have the social permission to experiment with the landscape at the scale. Alternatively, managers are just being asked to stand back and watch what happens, try to understand it, and then evaluate it. But I would say, and I'm not saying that an adaptive management framework isn't essential. It's probably more essential than it ever was. It's just that we don't have a clear endpoint for the management process. We don't have a clear future condition. And lacking that, and lacking an understanding of what the mechanisms are that get us there, I think it's a very, very challenging transitional period for people trying to maintain ecosystem sustainability.
But it seems just understanding where you are in terms of whether or not an adaptive effort then fits into persistence, recovery, or even in reorganization, that alone seems to be kind of an important realization that needs to happen.
Absolutely. And in fact, on that point, We've just recently done an assessment of how much we actually know just here in the Southwest about these transitions. And I hate to say it to this audience, but the amount of information we actually have is really sparse. Most of the public agencies don't have the staff or the capacity to monitor ecosystem change. The number of scientists doing working studies is fairly small. You can see some things, but not a lot by remote sensing. And so when I say we're sailing into the dark, it's partly because we really do not have a clear understanding of how much mortality, how much recovery, and how much reorganization is even happening. So that absolutely, I agree with you. That's an essential piece to figuring this out.
Thank you, Professor Falk. We are now going for a 5 minutes break, and it's 9:53 now. So we'll be back in 5 minutes for the panel discussion.
Yeah, I would encourage everyone to stay on, just take a quick bio break, and we'll be right back.
welcome you all again. We are going to start the panel discussion. The session will be moderated by Dr. Brian Enkist, a co-director of BBCS. He is a professor of Department of Ecology and Evolutionary Biology at the University of Arizona. He studies how functional constraints at the level of individual influence larger scale ecological and evolutionary patterns. His research also includes the monitoring of long-term dynamics of growth and change within a tropical forest. I now request Professor Brian Enkist to start the panel discussion session. And just a reminder that we had 3 speakers in the morning, and according to our plan, the 3 speakers would be present in our panel discussion, but Professor Kirsty Ibai had some family emergency, so she has to leave early. So now we will have Professor Robert Costanza and Professor Donald Falk in the panel discussion, moderated by Professor Brian Enkist. So please, Professor Brian Enkist, start the panel discussion.
Great, thank you very much, Abu. I wanted to thank kind of all of our speakers, series of excellent talks, quite thought-provoking and important. So I would like to start here by just sending a reminder then to everybody then online to please place any additional questions that you may have in the question and answer section then in the Zoom meetings. If you go to the lower at the bottom kind of right of your Zoom screen, you should see a Q&A link then to click. So please submit any additional questions that you may have. So we've been monitoring then both the chat and the Q&A, and so we've been accumulating several different questions sent. And so I think what I'll do is kind of step back, and to get the discussion started, I'd like to just ask a little bit more of a general question to our speakers here today. And maybe I can start then with Dr. Costanza, and then Don, then we'll switch to you. But I would like to ask, kind of given that we just have this recent IPCC report this week, I was curious to know what you think we should pay attention to in terms of this IPCC report, especially relative to not only your talk, Dr. Costanza, but also to this session that we're focused on today.
Okay, well, I think the main takeaway that I got from it was that there's increasing emergency to do something, to actually turn things around. That we've been studying these phenomena for quite a while now, but I think there's the recognition that time is running out, and if we expect to actually achieve the goal of 1.5 degrees, it's still not impossible, but it's becoming less and less likely unless we can really change things. From my perspective, it just sort of reinforces what I was saying, that it's hard to overcome addictions. Addictive behavior is very strong. It's very hard to get addicts to change their ways, especially if the drug continues to flow. And our inability to really constrain the fossil fuel sector is part of what's I think slowing the transition to renewable energy and solving the climate crisis. So the COP in Glasgow, I think it was the first time in all of the COPs that they even mentioned fossil fuels as a problem, as part of the problem. So those special interests are really way too much in control. I mean, we're continuing to subsidize fossil fuels. Maybe the Ukraine crisis, will have a positive silver lining in that regard, and to wean Europe off of oil from the Soviet Union from Russia. So I think there may be some things that crisis can contribute to, but I think another aspect that I think we could talk about is this idea of thinking of the atmosphere as a common asset, rather than putting all the weight on governments to implement programs. We could say it's the responsibility of the entire global community. Civil society needs to get more involved in this? How do you get civil society involved? We'll make it clear that this is all part of our global commons. We all benefit from a good atmosphere. It's not something that's happening sort of out there. It's not something that the government needs to take care of. So we've proposed this idea of an atmospheric trust. And if we could get enough governments to go along with creating that trust, then that could be used as an overarching institution within which you could begin to charge for damages to the climate. It's once you've said it is common property. So we could begin to use all the property law that exists out there and say, those who damage our property need to be held accountable, and start, so it gives a more legal basis for some of the carbon taxes and cap and trade issues that are out there. But then it also says explicitly what needs to happen to those funds. They need to go back into protecting the asset. They need to go back into restoring ecosystems, into encouraging renewable energy, also into reducing poverty and achieving some of the other SDGs. So I didn't see anything like that in the IPCC report. There's more of how bad it's getting and how fast we need to change. But I think we need to think in a lot more innovative ways about how to actually address this addiction that we face. Thanks.
Great. Thank you. Don?
You're still on mute, Don.
Yeah, you're muted there, Don.
Somebody has to do that at least once, right?
Yeah.
So when I read that report, the image that came to my mind is that we've jumped out of an airplane and we're arguing about how long we're going to wait before we open our parachute, right? And we're just in free fall, and we're thinking, this seems fine, kind of a nice view up here, and we haven't hit the ground yet, so let's wait a little bit longer before we open our parachute. And how long do you wait to do that before it's simply too late and you're going to come crashing to the ground, even if you open it at the last minute? And I kind of think that's our situation. From the perspective of ecosystems, they have a strong inertia, and that inertia can be both very beneficial but also very alarming in many ways. The inertia includes their stored carbon, their stored biomass, the complexity of ecosystems, their evolution to climate variability and other factors. There's lots of ways in which ecosystems can absorb these kinds of stresses over time, but it works the other direction. Once change has been set in motion, it may be very difficult for us to reverse it. In many ways, that people have looked at the longevity of greenhouse gases in the atmosphere. We could ask the same thing. We could posit the same thing, that there's a kind of ecosystem inertia towards change, and we're just seeing the leading edge of that through the expression of mortality, for example, and failure of ecosystems to recover back to their previous state. So it's a huge factor. Bob mentions the idea of an atmospheric trust, and of course we could take all three of the global biomes, the land and the ocean, and apply the same kind of thinking. The land is a little more problematic because humans have lived on it for a long time, so they've divided it up into private property long before they did that to the oceans and to the atmosphere. But the same fundamental principle applies, and it's challenging to know a pathway to get there. But there is absolutely a collective global stake in how ecosystems adapt to the conditions that they're being exposed to. And it cuts directly across the grain of a lot of private property and a lot of industrial economy to do that. So my sense of this new report is simply an acceleration, not only acceleration of the driver of change, but also a reminder that we don't have good metrics, we don't have good measures for the extent of ecosystem change and how quickly that's progressing. So papers like the Hammond paper that I showed earlier, these are point observations of mortality, dieback, forest dieback, and we need hundreds, if not thousands of times more detailed data of where ecosystems are actually changing, because we don't have the signal. In the atmosphere, we think that we can reduce the change to a few metrics. Greenhouse gas concentrations, for example, are a very powerful metric. There is no equivalent metric for ecosystems to tell us whether they have initiated an irreversible phase of change or whether they are simply adapting. So those are some of my thoughts with that report.
Thank you, Don. We have another question here. This is from Dave Brashears. And Dave asks, this is directed to you, Dr. Costanza. What thresholds are reached that cause the divergence between economic growth and uneconomic growth in the late 1970s, early 1980s? Actually, I had that question too. What insights does that give us in terms of moving forward?
Well, that just happened by coincidence to correspond to the election of Ronald Reagan and Margaret Thatcher in the UK. That wasn't a coincidence, because that sort of kicked off the reversal really of the post-World War II reduction in inequality, and started going back in the other direction. And now the U.S. is more unequal than it's probably been in hundreds of years, really, since the Gilded Age, perhaps. So that's true of other countries as well, including China, including Brazil and several other countries. So the rise in inequality, I think, is one major driver. The other major driver is the damages to our ecological life support system, including climate, but also including many of the other ecosystem damages. I think those are the two main things that have changed since then. The scale of the human economy by the early 80s and beyond has gotten so big that we're having these major damaging side effects. And unless we can reverse that, I think we're headed for more uneconomic growth. So I think we really need to flip those two curves around and say, okay, it's not that economic growth is necessarily a bad thing, but it's what kind of growth, what things are you actually improving, and all those things on the negative, cost list are things you don't want more of. So how do we have growth that has less crime? That's a good thing. Everybody's going to be in favor of that. Growth that doesn't damage the climate, that doesn't damage ecosystems. If you can pull that off, that's fine. But the main goal should be really this more comprehensive view of what we're trying to achieve, which is sustainable well-being. And Don was talking, I think, about how we really need better goals for managing ecosystems as well. And that's part of the reason that things are floundering, that nobody's clear about what is it we're trying to achieve. And if you don't have a clear goal, you end up somewhere else, as I said. And maybe I could ask a question too while I've got you. So it seems like in the literature, a lot of times resilience comes across as a goal. We're trying to improve resilience. Well, and I don't think resilience is the goal. Resilience is a characteristic of these complex systems, and the goal is really well functioning ecosystem health, if you will. You want a system that's functioning well, and sometimes you can have too much resilience. I think of conventional universities. I think they get stuck in their ways, and they're over resilient and resistant, to the kind of change that might be beneficial. And I think that's it's kind of the addiction metaphor as well. If you can get too stuck in a particular mode of behavior and resilient to change of that mode, but if it's not a good mode, if it's heading in the wrong direction, you don't want that resilience. You want to somehow break down that resilience and make a positive transformation. And part of the problem is we're headed towards a negative transformation, and we want to flip around and try to make a positive transformation, but sometimes the resilience in the system gets in the way of that. So I think that's something we need to make clearer, that resilience is not the goal. Positive behavior and well-being and health, I think, are really the goals for these complex systems. How you define that, I think is difficult, but I don't think it's impossible. And I think we can construct the parameters that we're talking about for a healthy ecosystem that's not dependent on just saying that it's healthy if there's no human impact. I mean, that doesn't really help us very much. You have to come up with a much broader definition of what's a healthy functioning ecosystem, how's energy and materials flowing, et cetera, et cetera. And, invasive species, they can be, migratory species, they might be a positive contribution. They might be negative, but I think we have to be able to distinguish those, those two characteristics. So maybe Don, you want to respond to that?
Yeah, well, so just very briefly, you're absolutely right that resilience per se is not a goal. And a great way of appreciating that is to ask what the metrics are of resilience. What's the measure of resilience? Well, most people, you can't name one because it's an emergent property. It's comprised of thousands of individual mechanisms and responses. And so the crux of the matter really is not whether the system acquires this property of resilience as however you define it, but what that looks like inside. And I gave the example of a couple of cases where systems transition into highly resilient states that really are not doing anything good ecologically or economically. It's also absolutely true that as climate changes, even with the bending of the curve, that the global ecosystems are going to reorganize as they have many times in the past. That in itself is not an unusual or a natural outcome. It's unnerving that it's happening so quickly and it's happening on our watch and it's being driven by things that we did that are not part of the natural cyclicity of global climate. Those things all are disturbing to us, but from an ecosystem point of view, they're just adapting to changing conditions. And so I think the hard thing is to identify a clear baseline. In your comments, your question about what that future state looks like, a big problem in biological conservation is the shifting baseline, the loss of memory of what things used to look like. Who grieves for American chestnut or elm in the eastern forests? Probably a handful of people know that they're missing, but most people don't even know. Who grieves for the absence of bison in the Great Plains? Again, it's just not part of our individual experience. So we have a great ability, whether it's a good or bad thing, to let go of things that have been lost. And that may be a good thing in terms of our not being excessively disturbed about things we can't change. But it also means that we lose that sense of history, and the history of an ecosystem is an inherent part of how it works. So I would say that middle path is some recognition of the inertia and history of ecosystems, which we shouldn't simply rewrite. It shouldn't simply be a kind of palimpsest of replacing things we want with things we want, but at the same time recognizing that this change, painful and unexpected as it may be, is inevitable, and the evidence suggests that it's happening. Is it fair for me to ask a question back to Bob? Because while I'm speaking, I wanted to ask you.
Yes, hold on. I want to help guide this discussion just a little bit here, because we had an additional question that is related to this.
Okay,
great. And now that I have you here, Don.
Okay.
So the question is actually from Jose Soto. So put a pin then in your question for Bob, because I think we're gonna pivot back to Bob.
Yeah.
And so Jose then asks, in your experience communicating science then to broader audiences, okay, what are the major then barriers or enablers to effectively do so? And so this is kind of related then to Bob's then commenting then on therapy or kind of addictions, right? But trying to then kind of understand this more in the light of how you're kind of studying the problem.
Who is that directed to?
I'm sorry, that's to Don.
Okay.
Sorry, that sounded more like a Bob question.
Well, in terms of communicating science then to broader audiences,
I
in
see.
terms of
Yeah.
of working then with land managers.
Yes. Okay.
In particular.
Right.
Okay.
Right. Okay. So a student of mine just recently finished a study looking at public attitudes towards ecological change here in the Sky Islands bioregion, and that includes the effects of severe wildfires and more intensive management treatments. And she found that there is a lot more public acceptance of change than we would have found even just a decade ago. I think that there is recognition that change is inevitable. It doesn't mean people like it. They want to be able to go up and see the forests that they grew up with and they took their kids to. And those things are disappearing very rapidly, and that is disconcerting. And I think in a lot of cases, people view that as an unfortunate outcome. But I would say that there is increasing acceptance that change is happening, and it's being driven by very powerful global physical and economic forces. And so my sense is that for both the public and for people trying to manage lands through this very uncertain transition, the change is no longer a question. Whether change is going to happen is no longer a question. People do have sideboards for what they consider acceptable change. And hopefully the human sideboards correspond to the sideboards of a healthy ecosystem as we might define it ecologically. So I think there is a space in which we can find a way forward. There's certain things that people are always a little uncomfortable with. That people don't like having large predators in their backyard, and we know that when you pull large predators out of an ecosystem, you have a cascading other changes. So there are some limits to how far we're going to be able to get to this with our current land use in the landscape, and that's certainly here in North America, but globally as well. The reason tigers are disappearing and elephants, a lot of these human conflicts. But I'm seeing, I think, a lot of understanding that change is happening, and people are more accepting of managers trying new things up to a point, and we don't know really what those, I'd say we don't know what those limits are.
So bouncing this then back to Dr. Costanza, do you have anything to follow up on that, especially in terms of how it relates then to this addiction that you emphasized?
Yeah, I think the general public responds much better to sort of narratives and stories. And I think to the extent that you can build those sorts of narratives and make them as compelling, as engaging as possible, that's going to have a better acceptability and for people to understand what you're talking about. So we started a publication about 12 years ago now called Solutions, and the idea there was we wanted a sort of hybrid between the sort of academic papers and the sort of fluffy magazine articles. We had people writing about science, and we had scientists writing, but there was no real middle ground where people are talking, and particularly one focused on what actually works. I think people hear too much about the problems and not enough about how to solve those problems. So our rule of thumb for the magazine was that no more than 1/3 of the article could be about describing the problem, and 2/3 had to be about describing the solutions. So you can find it online, and I think we could do more of that kind of writing and communicating. We engaged some journalists to help with that, but we had the journalists working together with the scientists in order to make these articles more readable, more compelling, tell the kind of stories that I think people could understand. The Conversation is another publication that's sort of headed in that direction. Not really focused on solutions as much, but definitely having that more engaging kind of style. So I think that's one approach. How do we really write these stories in a way that people can understand, and also can we begin to talk more about solutions and not just the problems.
Dr. Costanza, I wanted to ask you a question associated with the nature of kind of tipping points. And so we've kind of focused and emphasized a lot in this workshop on concepts like resiliency. But there's this other kind of concept that hasn't necessarily been addressed, but I think all the speakers kind of emphasize that there's this notion of a tipping point. That is this surprise where the system goes from a previous state all of a sudden, to another state. And what I've been kind of picking up on from not only the literature, but also kind of the general kind of zeitgeist out there, is that depending on if you talk to some of the climate modelers and look at, as you increase temperature and Earth system models, kind of what happens, they don't necessarily see large evidence for big tipping points and things that come out of these models. And so when I talk with some of these modeling folks, they're like, well, discussion about tipping points, maybe that's overblown, but it seems to be still a big component then of the zeitgeist out there. And so I'm curious to know kind of your thoughts on not only this term tipping point, but if it's something that could actually be more polarizing actually within the scientific community.
Okay, thanks. That's a great question. And I think part of the reason that the climate models don't see tipping points is that they're not constructed in a way that really sort of allows that kind of behavior. I think in the real world, complex systems exhibit these kinds of tipping points, both natural systems and social systems, do that kind of behavior. So I think it's a criticism of the models more than it is a criticism that, you don't want to, my favorite saying is that all models are wrong, but some models are useful. And I think the current group of climate models are not that useful for predicting tipping points, just because of the way they're structured. They're useful for other purposes. They're useful for saying if things continue the way they're headed, this is kind of the behavior we expect with certain assumptions and parameters built in. So in terms of it being polarizing, I guess you could say that any proposition in science can lead to a divergence of opinion, and that brings up a whole nother idea, which is this idea of the it was, I guess, Deborah Tannen who wrote a book called The Argument Culture several years ago, and her point was that our whole culture is based around this idea of debate, and things are black and white, and somebody's right and somebody's wrong, and the law and academia and the whole culture is really built around this essentially polarizing approach to discussing anything. And in some cases it's good that there is a right and a wrong answer, but in these many cases, the system is much more complex than that, and you can't say that there's a right and a wrong. It's really what we need is a much more nuanced discussion, and that may require building a whole different culture within which to have that discussion. One that doesn't presuppose a right or wrong or a polarized, whose side are you on, kind of thing. So I think that's partly what we've been trying to do in ecological economics, is to say that we're not saying this is a whole different approach to economics, and it's completely different from standard economics, and it's completely different from ecology, and we're going to bite it out. No, we're saying all of these ideas and disciplines have something to contribute. How do we sort of bring them together and have a really fruitful discussion and say, let's see what works, and let's use the best of all of these ideas and put it together in a more discursive, productive kind of way, and try to build more consensus rather than to simply continue to argue.
Okay, thank you. So tipping points are not included then in our global models. So Don, any comments then on that?
Yeah, so, well, Bob just gave a very ecological answer, which I really appreciate. And it's true for ecosystems too. There is no black and white. There are very, very few black and white binary states. And like economies, global ecosystems are endlessly variable in time and space. I would mention also, the tipping points may occur, but they may occur at very, very small scales. when we look at these outcomes of ecological change that is staying the same or recovering following a disturbance or transitioning to something new, all three of those can be happening simultaneously in a single landscape. So it's not as if there's an absolute, most commonly, not as if you go sort of over a single absolute threshold where the entire system goes down into a roller coaster going into some new state. That's, you know, the image we get from the ball and cup models that assume that everything is rolling all in the same direction, all at the same time. And that rarely happens. You have individual species falling out and new ones coming in, or individual processes that are being compromised or reduced, and other processes that are increasing. And so whether you take a species approach or a functional approach to ecosystem, you would rarely see this kind of wholesale unitary conversion. It's happening piece by piece. And this is good news in the sense that those early changes can be early warning signals of more pervasive change, where one component, for example, the survival of a particular species, maybe has gone past a tipping point, and the example might be the sort of seedling failure that I mentioned earlier, where the young individuals of one species reach their limit of their ability to survive, and that species now falls out, is no longer reproducing. That may be a single species, but it may also be an early warning about behavior of the larger complex system.
Okay, so thank you. So we're getting close to the end, but I wanted to just circle back because I believe, Don, you had a question?
Well, just a very quick question for Bob. I wonder if you could say a word about how world human population fits into the scenarios that you're describing. I mean, obviously, a lot revolves around the per capita resource intensiveness of our lifestyle, but there are also the number of people and with very, very widely ranging resource uses. So just interested in your thoughts.
Well, I think you have to consider both of those elements, you know, the number of people and the consumption per capita. And I think if we were able to reduce the gap in income globally, I think we would sort of almost automatically deal with the population issue. At least that's how the demographic transition has seemed to work. And also there's an information and a sort of cultural bias as well. You know, that if we just eliminate all of the unplanned pregnancies and unwanted pregnancies in the world, we could stabilize population almost overnight. So it's really, education of particularly of women to sort of give them more control over their reproduction, and that gets back to the planning and also access to contraception, and just think about how the world could be if we didn't have to worry so much about those sorts of issues. So I think we could solve those problems in a way that's sort of interconnected with solving some of the other problems, like inequality, like job insecurity, so the kind of world that I think we could envision, where all of those problems are kind of solved together, I think is one that we need to communicate to people and say, look, this is how the world could be. Isn't that what we're trying to achieve? Whereas right now we're asked to vote on individual issues out of context, essentially, and toward a goal that nobody has really articulated. So it's almost as bad as managing ecosystems when you don't know what's going on, if not worse. We don't have a clear goal, and so we're obviously going to be heading off in all different directions, and it's not helping.
Thank you.
Now you're on mute.
Yeah, I just noticed that. Thank you very much. Excellent discussion. I would love to continue this. Unfortunately, we have the reality of set times here. And so I'd like to pass the baton back to Abu. So Abu.
Yeah. Thank you very much for this lively panel discussion. And it has been very informative and insightful 2.5 hours. I'm sure that we could spend days discussing each of these fabulous presentations. And it's great that so many of you could attend. We received registration over 80, and then a great part of the registrants who are joining us back and forth. And then I appreciate those who stayed to the end. And please join me in thanking our phenomenal speakers for sharing their research and experience with us. And thank you, Professor Robert Costanza. And thank you, Professor Don Falk. And also we thank Christy Vai, who left because of some family emergency. So I would like to end by leaving you with thinking how each of us can contribute to the global prosperity. And we have learned many from our speakers today. Let's make it possible for the sake of those who are most vulnerable and who are still continuing to live in poverty. Finally, I would like to thank all the BBCS faculty members for their support during the preparation of the event. And big thanks to BBCS coordinator, Carrie Johnson, for her hard work to complete all the administrative works for the webinar. Lastly, we acknowledge the incredible tech support during the session, who ensured the session goes on smoothly. And thank you all once again. We will be sending post-webinar evaluation survey shortly, and your feedback will be much appreciated. And keep an eye on our website and Twitter at Arizona BBCS for our research and news about the future events. And we wish you to see in our next event. And stay safe, take care, and goodbye.
Thank you very much.
Bye-bye. See you.
Thank you, everybody. Bye-bye.